Alright guys, welcome to this page of the notes, and what we're going to do here now is just get some practice using that parallelogram theorem, where the theorem gives us the relationships between the sides, the angles, and the diagonals of a parallelogram, and we're going to use those relationships to go ahead and see if we can solve some problems here. So let's go ahead and jump right into it. Again, based on the properties of parallelograms that we just talked about, we can find unknown lengths and measures. We can do some algebra. So let's jump right into it. I give you this parallelogram A, B, C, D. Here is our parallelogram over here. Let's go ahead and find AD. I want you to find that length right there, AD. Well, here's what we know about parallelograms. I know that this guy right here, AD, is parallel and congruent to BC. How do I know that? I tell you it's a parallelogram, and thanks to the parallelogram theorem, opposite sides are parallel and congruent. So I know that AD is congruent to BC. Well, great. I know something about BC and AD, so let's go ahead and set those guys equal to each other. AD is 7x. BC is 5x plus 19, and we're just going to go ahead and solve for x, right? We set up, thanks to the geometry, right? Knowing this geometry about parallelograms, I can set up this algebra problem. Now we just solve the simple algebra problem. So here we go. I'll subtract the 5x to the other side. 7x minus 5x is equal to 19, which means 2x is equal to 19, which means x is equal to, what is that going to be? 19 halves, or 9.5. We'll do 9.5. Now, I asked you to find AD, so all we got to do is just plug it back in, right? I didn't ask you to find x, I asked you to find AD. So let's go ahead and finish this problem off by doing 7 times 9.5. I get AD is 6.5. Right? So again, we're just using the theorems that we learned about parallelograms to help us set up a quick algebra problem that I can quickly solve to find my unknown length, side AD. Conversely then, what I know is that side BC is also 66.5, right? Because opposite sides of a parallelogram have to be congruent. Okay, let's keep going. I want you to find the measure of angle B. Well, there's angle B right there. In fact, let me go ahead and erase that. And angle B is this guy right here in green. That guy right there. Well, here's what I know about parallelograms. Thanks to the theorem we just talked about, I know that opposite angles of a parallelogram have to be congruent, which means B must be congruent to D. Right? So based on the theorem, I know that angle B is congruent to angle D. Well, that idea lets me set up an algebra problem. I know that B is 6y plus 5. I know that D is 8y minus 17. So set up your algebra problem and solve. 6y plus 5 is equal to 8y minus 17. I'll subtract the 6y to this side. I'll add the 17 over here. I wind up with 5 plus 17 is equal to 8y minus 6y. Let's come up over here. So what do I wind up with then? I wind up with 22 is equal to 2y. Divide both sides by 2. We get y is equal to 11. Careful, I didn't ask you to solve for y. I asked you to solve for the measure of angle B. So we just got to plug it back in. Angle B was 6y plus 5. So 6 times 11 plus 5. I wind up getting 71 degrees for the measure of angle B. All right, guys, and there you go. A great example problem of ways that we can use the theorems about parallelograms to solve for unknown lengths and measures. Let's keep going because I got a really good question for you right here. I want you to suppose you wanted to find the measures of the other angles, right, of that parallelogram I just had up above. Here's what I mean. Take a look at this. We just found the measure of B and D. We just found B and D. We know opposite angles are congruent. I'm asking you here in this question, what if you wanted to find the other measures, right? Find the measures of the other angles. What angles am I talking about? I'm talking about these angles right here, A and C. Now again, you know that opposite angles have to be congruent. So you know that angle A and angle C both have the same measure. My question is, how could you find those angle measures? Go ahead and explain how you could do this. Well, we have a couple of options actually. First, this one. Please recognize that AD is parallel to BC, right? Those blue lines are parallel. That's right, you can see where this is going. We're going all the way back to chapter 4. Sorry, hang on. Apologize, there we go. Going all the way back to chapter 4, where we have parallel lines cut by a transversal. Remember the angle relationship, right? I have angle A and angle B, which are what we called same side interior angles. Now, do you remember what same side interior, what was the relationship between same side interior angles? Hopefully what you remember is same side interior angles must sum to 180 degrees. That was the relationship. If you forgot, there's your reminder. Absolutely, I expect you to be able to use that information. So we know same side interior angles, angle A plus angle B sums to 180 degrees. Well, I already know the measure of angle B, so I plug it in, subtract it to the other side, and I get the measure of angle A. That's one way I could do this. Another way was our Polygon angle sum theorem. All right, the Polygon angle sum theorem, hopefully you remember this equation. We had n minus 2 times 180 degrees. What this equation told us is you take the number of sides of the polygon. In this case, we have a quadrilateral. This entire chapter is about four-sided figures. So I would do 4 minus 2, right, which of course is 2. 2 times 180 is 360. So what the theorem tells me is that the interior angles of my quadrilateral must sum to 360 degrees. 360 degrees. Well, I already know B and D, so I can subtract B and D from 360. I know that A and C are congruent, so then I divide by 2, and I can find, using this Polygon angle sum theorem, I can find the measure of A and C. Again, more than one way to do this problem. I don't care which way you do it, if you want to use the same side interior angle theorem, or if you like this Polygon sum theorem. I probably, when we get to these problems, will go back and forth between the two. I'll just alternate which one I use so that we can get practice using each of them, but that's a great way to do those. All right, I think I got one more example problem for you here, just setting up some algebraic expressions to go ahead and solve. So let's quickly run through another one of these. This shouldn't take too long. I want you to find QR. There's QR. QR is parallel and congruent to PS, its opposite side. So set up 3z minus 4 is equal to 2z plus 4, right? I know opposite sides parallel and congruent. Let's quickly solve this algebra problem. 3z minus 2z is equal to 4 plus 4. That gives me z is equal to 8. I didn't ask you to find z, I want QR, so let's plug that back in. Oh, whoa, not 8, I want QR. QR is equal to 3z minus 4, which is going to be 3 times 8 minus 4. What did I wind up getting there? Yeah, 3 times 8 is going to wind up being 20. So QR, I apologize, I don't know why I keep writing an 8. Well, QR winds up being 20, whatever units, 20 units, thanks to solving that algebra problem. I want you to find PR. Ooh, fantastic. This is a question now about diagonals. Please notice, right? This diagonal is PR. Well, let's think about our theorem. What do we know about diagonals? Diagonals of a parallelogram are bisected. So what that means is these two segments, PT and TR, are congruent because I know that my diagonal is cut in half. So I know that PT is congruent to TR, right? That's thanks to the theorem of parallelograms. Well, I know something about each of those. X plus 9 is equal to 4x minus 6. And here we go. 9 plus 6 is equal to 4x minus x, which means I wind up with 15 is equal to 3x. X is going to be equal to 5. Okay, great. Now I need to find the entire length PR. Well, as long as I know one of the segments, since it's bisected, I'll just multiply it by 2. If I know PT, multiply it by 2 to find the entire length, because both segments are congruent. So we'll find PT, which is x plus 9, 5 plus 9, so that's 14. I know PT is equal to 14, which means the entire length would be 2 times that. So PR must be 28, right? Guys, that's a great way of using the theorems that we just learned about parallelograms to solve some problems. Head on over to the next page of the notes. We'll take a look at a few more example problems. I'll meet you there.